Ever wondered how AI can learn new things without forgetting the old? It's like learning to ride a bike, then later picking up skateboarding, without suddenly forgetting how to balance. But here's the catch. AI models often suffer from catastrophic forgetting, where learning something new wipes out what they already know. Today, we're diving into a breakthrough called direct fine-tuning, DFT. That's rewriting the rules of continual learning in computer vision. Let's start with the problem. Traditional AI models are trained on fixed datasets. They learn to recognize, say, dogs and cats, and that's it. But the real world is always changing. New objects, new contexts. Researchers want models that can keep learning, like a student who studies new subjects without forgetting their old ones. The issue? When AI adds new knowledge, it often forgets the old. It's like trying to memorize a new phone number, but losing the old one in the process. For years, people dismissed direct fine-tuning, DFT, as too simple to work. Why? Because when you tweak a model to learn something new, the classifier part, the AI's decision-maker would drift, making it seem like the model had forgotten. But here's the twist. This research shows the core vision system, called the Perceptual Visual Module, PVM, is actually retaining its old knowledge all along. So how did they test this? They used a clever trick called probing performance, like checking if your brain still remembers how to solve a puzzle after learning new ones. They trained models like ResNet101 and Swin-B on datasets like Pascal VOC and ADE20K, then measured both observed performance, how well they did on tasks, and probing performance, how well their core vision system retained knowledge. What they found was surprising. Even as the classifier started to drift, the PVM stayed strong. The drop in observed performance wasn't because the model forgot. It was because the classifier got confused. This flipped the script. The problem wasn't the model's memory, but how it labeled things. So how did they fix it? They created DFT, a smarter version of direct fine-tuning. Instead of overwriting the entire model, DFT freezes the PVM, the core vision system, and old classifiers while only updating new ones. It's like locking in your bike skills while learning to skateboard. The result? DFT outperformed 16 state-of-the-art methods, with way fewer parameters and faster training. Think of it as a lightweight, high-performance upgrade for AI. This isn't just a technical win, it's a shift in how we think about AI. By rethinking what's easy and hard, this research shows that sometimes the simplest solutions are the most powerful. And the best part? DFT's efficiency makes it perfect for real-world applications, from self-driving cars to medical imaging, where speed and accuracy matter. But DFT isn't the only trick in the book. Let's break down other techniques, reshaping continual learning. Take knowledge distillation, a method where a big, complex AI model, the teacher, shares its wisdom with a smaller model, the student. The student learns the teacher's tricks while staying efficient, like learning to solve math problems by watching a pro, not starting from scratch. Then there's gradient-semantic compensation, a balancing act that prevents AI from overwriting old knowledge when tackling new tasks. Imagine learning to drive a car and a motorcycle without forgetting how to ride a bike. This technique adjusts the model's learning process to preserve prior skills. And let's not forget repulsion-attraction, a way of organizing knowledge. The AI pushes similar concepts apart, repulsion, and pulls related ones together, attraction, helping it distinguish between, say, a cat and a dog, even as it learns new animal categories. These methods aren't just theory. Scientists test them on real-world datasets like ADE20K, thousands of scene images, and Pascal VOC, object recognition benchmarks. These datasets act as training grounds, proving AI can retain old skills while mastering new ones. Why does this matter? Picture an AI that helps doctors diagnose diseases. It needs to learn about new illnesses without forgetting existing conditions. Or robots that adapt to changing environments, like a warehouse robot handling new products without messing up old tasks. The math behind these techniques is complex, but the goal is simple. Build AI that learns continuously like humans. No more forgetting old knowledge just because it's busy learning something new. So while the science might feel like magic, it's all about making machines smarter and more reliable. And with research like this, we're one step closer to AI that truly grows with knowledge, just like us. Thanks for watching. If you want to dive deeper into any of these methods, check the links in the description. Stay curious, and I'll see you in the next video.